Hey guys, Joe Pye here at Advanced Innovations. Welcome back to my shop. Yesterday's effort was the production of these little guys right here, and this posed an interesting challenge because it is so short. This was actually done in an arbor that allowed the part to go down inside of it. I'll show you what the blanks look like. Started off looking like that and ended up looking like that. This particular arbor is the manufacturing arbor, and it is hollow from behind, so the arbor could stay stationary and I wouldn't lose any of my readings on the digital for all the cutters and the rotary table work that was done. Now these were done exactly the same way as the long ones in the back, these guys. And I need to be honest to tell you that I was not looking forward to doing these guys because of the inherent challenge due to the length. And you really can't get carried away on it because that's a 540 thread. That's a 3mm, 125 diameter thread on brass. So I didn't want to break them off. Today's challenge and one of the closing elements is to make this little round hole in the end of this guy square. I'm going to try it two different ways, maybe one different way. But my mind tells me that I should probably set up the broach, punch these out square, and do it right. Once that's square, the wedges come into play to lock this whole thing together. The chassis is coming along nicely. This is the chassis in the back. And the tapered hole, or the tapered scallop mark right here, is simply done with a straight boring bar, and the block is set on an angle. And because the block removes more material in the back than the front, because it's on an angle, you get that tapered look. Mr. Compressor checking in, saying good morning. All right, let's move over to the mill. Set these guys up, get this done, move on. Before I take this piece out, I'd like to give you some idea of the scale of the machine that's being used. I'm going to go handheld here for a second. Try not to throw up. If you do, turn your head. Don't throw up on your keyboard. That's the tiny little piece right there in the middle. That slot is about 2.5 millimeters long, about 2 millimeters wide. I'm going to leave the original pilot hole witness mark on either side. I just want the top and the bottom flat. Let's make the wedges. A little closer look at the final product. Top and the bottom are squared off so that the wedge seats in there better than it would on a round. Ideally a tapered slot would have been best, but that's just pushing my luck. The wedge I will attempt to make is going to look something like this. This is probably pretty rough, and forgive me for that. This is the material I'm going to start with, and this is how I'm going to do it, back to back. First thing I got to do is narrow this down to about 2 millimeters. I know the slot is about 0.81, so I want this to go in there comfortably without too much side-to-side wobble. Short of using an adjustable parallel to achieve my height, I am going to side mill this, clamping one end at a time to bring it down to the desired thickness. Now that's not a bad way to go, but it's got to be done in a climb cut. So if you have a mini mill, make sure that your table is snugged up and sufficiently locked, just so it doesn't just run away with you. Let's put it in the vise, show you how it's done. I'll show you how I'm going to do it anyway. One of many ways, I'm sure. First thing you want to make sure you do is have the entire part supported against the back of your machine, or the back of your vise. And I mean, the height of the part has to be subsurface for the best results. I'm going to use a pin. I'm going to keep the pin biased to one side of the blank. This will make sense in a second. The cutter itself needs to go completely past the part for a full side climb mill operation. I'm going to be cutting from right to left, so the rotation of the cutter is driving this material against this jaw. And try not to run into your pin. I've zeroed out my Y digital. I'm going to take a measurement now and put the part back in and finish the thickness. Okay, here we go. I'm going to say that it is okay to take a second pass over a finished surface. Just make sure that it's a climb cut. At about 1.25 millimeters coming off of there, 51 thousandths imperial. And to take off the notch, I'm actually just going to turn the part around, do the exact same thing to the other side. In case there's a bow to the raw material that you're using, it is a really good idea not to stop in the middle of the cut. The material might flex and it might leave a witness mark. So maintain the travel across the part. The climb cutting forces will drive it against the back jaw. It will keep it nice and flat. And at the very end, don't sit still, because if the bow is there, naturally you're going to see a line. So at the very end, migrate the table away from the cutter, gradually ramp it out. And leave everything set to 0, because you're already dialed in. That is a very reliable, very solid technique, and I'll put a link to a video showing you how to make exceptionally thin parts that you can actually profile into the face of your material, put the part against the jaw, and then run the cut exactly the same way I did, and as the cut progresses, the part will actually just fall out. It's a beautiful technique. Well, there you go. That is 78 thousandths material, 2 millimeters, and now I'm going to make the wedges. Using a very similar setup to how the material was thinned down, I'm going to make a notch on the end. The height of the bottom of this cutter is zeroed out from the top of that parallel and then elevated to the thickness that I'm looking for. I will dive the cutter into the aluminum part and walk the cutter to the camera left until I see brass chips flying. That'll be 0, 0. At that point I can form whatever notch I want on the end of this part. I'm looking for 125 left over, about 3 millimeters worth of tang. 3 millimeters worth of tang, and 500 over. 12.7 millimeters, half an inch, 0.5, whatever you want to call it. Let's put the notch in. Then I'll turn the part around. I could do this end to end, but I'm once again relying on the climb nature of this cutter. Actually, it's the conventional nature of the cutter at this point because I want the material driven against the aluminum so that it doesn't clap. If I bring it around this side and do this side will have a tendency to lift as the material gets thinner. That'll make sense in a second. Here we go. I think you can see the shine on the top of that. This is now X0, and whatever I dial in will be the thickness or the projection of the little wedge. Bear in mind that the wedge is inverted in this setup. 500, here we come. The remnant left behind, the top will be the tapered section. That's what's going to cause it to lock. And the distance from the shoulder to the end is the thickness of the wood where the trunnion strap lays down. So I'm going to flip this around, do the exact same thing to the other side. So far so good. Now we're going to lay it down flat, put the chain hole in it, and start to profile the outside. A lot of this work will be finished with a file because it's not an elaborate piece. This is probably something you could do with a file anyway, but I chose not to do it that way. Here we go. Next operation in line is the chain link hole in the inner radius for the outside profile. This is a meatball operation. There is nothing precision about this, so I'm doing it with a pin. I'm lining up a pin tangent to the outside of the workpiece on the face and the side, both sides. This will be my incremental side on my digital, and this will be my absolute side, so I don't have to reposition the part twice. Let's start here. Why not? Why not? You're already here, right? Why go back? Okay, if you're scratching your head wondering exactly what that was, what happened? What did he just do? Oh, I don't want to say it. Oh, don't want to say it. Here we go. Back of the part will come down here. Blend into that radius that I just made. And then it'll go around it off like that. So there's your part. Did the inside radius. And this will be done either by hand or maybe I'll just pop it on a rotary table with a pin. It'd be real easy to pick up right now. Just don't take the part off. Do both sides and come back and relieve the web right there. And that should be the end of it. If you're curious what those holes are for, with the parts being positioned back to back, down the lower holes are the center hole. That's where the chain is going to connect. And the upper hole is the radius for the back contour. Using a pin the same size as the hole, I'm going to take the entire fixture over to the rotary table, clamp the fixture down, and just interpolate this side off and probably run that edge as well. The entire fixture has been relocated to the rotary table. Drill chuck with a pin in it. Drill chuck center is directly over the center of the rotary table. Everything is clean and green. We're going to shift the table off to the center of the second hole, top one, and just interpolate the bottom round. Should be quick. I've also relocated the clamp a little farther in so I get a good bite on this piece, because I intend to cut this piece off while it's in this setup. I'm going to go clockwise around the lower hole, starting at the top hole. Lower hole is over the center of the rotary table. Let's do this. Okay, moment of pure honesty here. I am feeling way too much resistance from this cutter, and if you got a good eye, you can see this cutter actually deflecting as it's hitting the brass. And for a high-speed cutter to deflect when it hits brass, not cool. I'm going to flip this upside down and start over. All right. I don't like using 4 flutes on soft material anyway. 2 fluted in. 3:30 seconds in, guys. 0.93. That was a close one. Ouch. Well, I can't tell you how much I didn't want to see that happen. That clamp is really tight, too. Obviously not tight enough, Joseph. Let's see what we got. All right. I'm about 15 thousandths away with all my numbers, so I am very happy that that jumped the way it did. Holy mackerel. Holy mackerel. There goes my nice setup. Okay, you see where I'm going. Got to do it off camera. It's going to take a while. Bummer. All right, somewhere between the last shot and this current shot, I came to the realization that I am taking the long way around with these parts, but since I started it, I am going to finish it. This is the new fixture that I'm going to use, and it will constrain the blanks so that they don't go anywhere unexpectedly. That was unpleasant, and I don't want to see that again. So here we go. I'll stick this puppy up on there. Lock it down. The pin's just going to keep it from sliding out. The track is going to keep it from going this way and that way. And the clamp is going to keep it down. Clamps should be used for holding parts down, not for keeping them from rotating or whatever else. Use a physical feature for that. Let's get back to where we were before the unfortunate shift in the workpiece. Let's see if we can finish this geometry up here on the top and the bottom. I am going to take a very superficial rotary cut to create a track on this side so that when the cutter comes around on the actual part, it doesn't load up and cause something terrible to happen. So that'll be the first thing I do. The cutter will be positioned. Right now the rotary table is the center of that pin, but the cutter is going to be up and over offset to the radius of the vertical leg right there. So it's going to be right back there in that corner. When you see a remnant like this jumping around, be very careful. If it were to pull back into the rotation of the cutter and get stuck between the cutter and the part, kiss it goodbye. Kiss the cutter goodbye. All right. That is a small one. All right, let's pop it out, see what we got. I'm hoping for something that looks like the print. And believe it or not, even after all of this clamping, this top part still tried to lift. I could hear it clicking. So I would not be shocked if there's some witness marks on there where it was trying to move. Very much like this camera. Let's see what we got. Yeah, you can see a little bit of noise on the top part. Overall, I like it. For what it is, that is just fine. Let's deburr it, put the taper on the top, make it work. Next operation after the profile is complete is to put this mild angle on the top. And when I say mild, that's about a 2 or 3 degree angle at the most. This is the fixture that I'm going to be using. It is incredibly primitive. This is an ultra thin parallel clamped on there at the desired angle, and the part will register right here on the corner. Now I chose this setup because I wanted something repeatable. It is going to be a trial and error trying to get these wedges to go on these trunnions right where I want them. So I wanted something that I could pop it off real quick and pop it back on. This will be held in a 6-inch Kurt vise on a parallel, standing upright. Camera will be in the front. Let's move over to the mill, set it up, and do it. Off camera, I am trying this, fitting this actually into the trunnion strap and cleat. And the wedge is so mild that advancing it only takes a couple thousandths of an inch off this top surface to make it move quite a bit. So I don't want to go too far because then it'll be loose. I will be doing this a half a dozen more times, so I will come back when they are fitted and show you exactly how they fit into the trunnion strap. But that's the part. That fussy little part. Let's take a look at the fit and function of those parts that we just completed. These are the trunnion straps. The barrel hangs right here. And for repositioning, transport, whatever, these things need to act like hinges and stay put when they don't want it to move anywhere. So these little wedges go right across the strap here. And because it's a wedge, the farther you push it, the tighter it gets. And naturally, when the wedge gets tight, it's hard to unloose it. Had to work that in there. The eyelets that I took so much time adding to this little thing will be anchor points for some decorative chain to be added after the fact. This is the chain that I've selected. It is going to go from that eyelet to an anchor point somewhere on the side, just a little piece, just so that the wedge does not get lost when it's removed. I am very pleased with how that came out. That was a little bit more work than I had thought it would be. I'm going to put a link in the video description, and if I can figure it out, maybe a little block right here with the link for the video that shows you a second way that these could have been done. And if I had more time today, I would put it back up on the machine and I would make another one just to prove it. But picture's worth 1,000 words. Go watch that video. I'm going to call this guy a wrap. We've got one more video left to do. There will be anchors in the corners here, one in the front. This is going to get stained and assembled, and probably stick a firecracker down the barrel, make it go bang to keep a lot of you guys happy. That's all I got for you this time around. Thank you very much for tuning in, spending some time with me today. Wherever you are in the world, I hope you are well and happy and safe. All of the above. That's enough for me for one day. Show Pie here at Advanced Innovations. I'm out.